Today we'll be moving on to our third objective, the circle geometry theorems. The first theorem that we'll look at is saying the angle or angles subtended by the common chord or arc are equal if they are in the same segment. For example, this particular arc, let me label it as arc AB. So this particular arc is subtending 32 degrees over here and 32 degrees over here. So since these two angles, the 32-degree angles, are subtended by the same arc, it means that the angles are equal. Let me go over and label them as arc A and B, and then I'll label the two corners of the angles as C and D for illustration purposes. So this will be A, B, where we get arc AB, and then this corner over here will be C, and this is D. So the angle AGC and angle ACB are equal because they are subtended by the same arc, which is arc AB. So you have to take note that this can also be a chord if you are to draw a line from the point A to the point B, but that does not change. The theorem is saying by the same chord or arc. So even if this were a chord, it would still apply. The theorem will not change. So let me put a straight line over here so that you can see what I'm talking about. So I've drawn a chord AB. You have to take note that even if the chord or the arc DC is being considered, this particular angle DAC or CBD, they will still be equal because they will be subtended by the same arc CD. And then moving on to this diagram, if we consider the arc AD, the angle ABD and the angle DCA will be equal because they are angles subtended by the same arc. We can also draw a straight line from A to D, and the theorem will still apply because the straight line from A to D will be subtending the angles at this particular corner C and the corner D. And then you have to take note also that if we consider the arc BC, the angle BGC and the angle CAB are equal because they are subtended by the same arc. We can draw a straight line from B to C, and the angles will still be the same, and the theorem will still apply because we said angles subtended by the same chord or the same arc are equal if they are in the same segment. So let me go ahead and give you questions that can help to test how much you have understood. Before we move on to the questions, we'll be attempting these two circles, the angles for these two circles. Let's first look at this particular circle where arc AB is subtending 1, 2, 3, 4 angles. But since they're all on the same segment, it means that the theorem still holds. The number of angles being subtended, it does not matter. So here we have 1, 2, 3, and 4 angles. Since they are all subtended by AB, these angles are all equal. So for instance, if the angle A1B was 35 degrees, it means that this angle is also 35 degrees, this one is 35 degrees, and this one is also 35 degrees. This is because of the theorem which is saying angles subtended by the same chord or same arc, which is AB in this case, are equal if they are on the same segment. So all of these are in the major segment, therefore they are equal. And then you can take your time to pause the video for 5 minutes and you can attempt these questions. You find angle X, angle Y, you also find angle X and angle Y here. I take it that you have gone through the questions and you have attempted them on your own. So when we apply the first theorem which we have looked at, saying that the angles subtended by the same arc or the same chord are equal. So this particular chord is subtending 38 degrees over here. This means that this angle is also 38 degrees and this one is also 38 degrees because they are subtended by the same arc. And then going on to this circle, we can see that this particular arc is subtending 30 degrees over here and this particular arc is also subtending angle x over here. Therefore, angle x is also 30 degrees because of that theorem. And then when we move on and you consider this particular arc is subtending angle y over here, and the same arc is subtending 40 degrees over here. Therefore, 40 degrees and angle y are equal, meaning that this particular angle is also 40 degrees. And then we'll move on to our second theorem. The second theorem says that the angle at the center is twice the angle at the circumference. So note that for this theorem to apply, you have to be told that this is the center of the circle. So here we have a circle center O with G, P, and S on its circumference. So the angle TOS is 2x, and then in order to find the size of the angle TPS, you say 2x divided by 2, which is x. So note that this could be 300 degrees, for instance. So in order to find this particular angle, the angle x, you will say 300 divided by 2, which will give you 150 degrees. And then in some cases, you can be given the size of the angle on the circumference, and you'll be told to find the angle in the center. So the angle at the center will be twice the angle at the circumference. For instance, if this were 15 degrees, the angle at the center will be 30 degrees. If this were 25 degrees, this will be 25 times 2, which is equal to 50 degrees. And then moving on to this circle, we are told that the angle A or B is 81.2 degrees, with O being the center of this particular circle. And then in order to find the angle AGB, we can see that the angle AOB and the angle AGB are subtended by the same arc or the same chord. Therefore, this angle will be 81 divided by 2, which is 40.6. And then we are also told to find the angle ACB. So the angle ACB and the angle AOB are subtended by the same arc. Therefore, this angle is 81 divided by 2, which is 40.6. And then also we can use the theorem which we have gone through previously. So the theorem is saying that the angles subtended by the same chord or the same arc on the circumference are equal. So after you have found this to be 40.6, you can say that this one is also 40.6 because they are subtended by the same arc or the same chord. So here is a recap of what we have done so far. Until next time, please make sure that you subscribe and you tune on so that you can stay tuned on for the next coming videos, and also invite your friends so that you can all enjoy together on this science cruise.